Hello, this is Robert, and in this video I would like to discuss arrays and array initialization and how to pass an array to a function. So I've set up this program, and inside of the main function I have an integer array called my numbers, and then I have a string array called words. My numbers is initialized using a list. And so here are the list of values that will be stored or initialized for my numbers right there. I'm using a global constant called array size to set the size of the array, and you can see that array size is set to 5 right there. And I've initialized each location with this initialization list. If I have one too many, then I will get a syntax error. So I have to have either just the right amount of values, or I have to have fewer values in the list than I have elements in the array. So let's take a look at an example where I have fewer numbers in the array. So if I have 5 locations, let's put 3 values in there. So location 0 will get 7, location 1 will get 5, and location 2 will get 11. All the rest of the locations, the other 2 locations in the array, will store the value 0, or will be initialized to 0. Let's go ahead and put a breakpoint right there so we can take a look at the array in memory. Modern compilers allow you to open up your arrays and see what the values are. So you can see here that at location 0 we have 7, 1 contains 5, location 2 contains 11, and then 3 and 4 contain 0. And that's how array initialization works. If we would like every single location to contain 0, all we have to do is create an initialization list with 0 as the only value. So the first value will be initialized to 0, or the first index will be initialized to 0, and then all of the rest of the locations will be initialized to 0 automatically. So you can see that all the values in the array are set to 0. If we leave off initialization, then we are back to an undefined set of numbers. So depending on the compiler, there might be garbage in there, or it might be set to a value used by the operating system. So you can see in this case that location 4 basically contains a garbage value right there, because we didn't initialize my numbers. Okay, so let's go ahead and take a look at the other way that we can initialize an array. Let's say that we have a very large array that we want to use. So what I'm going to do is I'm going to change array size from 5 to 500. Using this constant, by the way, allows me to update my array size very easily. I can set the array size to any value that I want, and then all I have to do is recompile, and my new array will be however large I need it to be. Let's say that I wanted it to be twice the size that I had before, so now I have an array size of 10. I'm using array size here and array size there. I'm also using it as my loop counter limit. So there's array size for the loop for initialization, and down here in my arrays I'm using array size right there as well. I could use literal values like 10 if I wanted to instead of array size, but now what I've done is I've made it more difficult to update my code. Let's say I'd like to go back to only 5 elements in my array. Now I have to track down every location where I used the literal 10, and I have to change it back to 5. Okay, and that would be really tedious and error prone, particularly if your code reaches, 200 or 300 lines. By using that constant up there at the top, all I have to do is change the value in one place, and then all of the values will be updated. So let's set this back to 5, or let's go ahead and put it at 500 for just a minute. Once we reach, I don't know, maybe 10 or 20 values, this list initialization becomes unworkable, because can you imagine having to list 500 different values for each element in your array? The initialization list would be very long. Okay, the other option to initialize an array that's large is to use a loop right here. So I have a for loop that starts at 0, because all indices for arrays start at 0. It stops at array size, so the last time through the loop will be array size -1, which in this case will be 499. And that's what we want, because remember that the last index is 1 less than the array size. So this loop will stop when we reach 500, and 499 will be the last value that makes the loop condition true. So 499 will be the last time through the loop. What I'm doing here is I'm initializing all of the strings in words to the null string or the empty string. And so 2 double quotes side by side means the empty string. No characters are in each string. Okay, so this is array initialization using a loop. Okay, so I've set up a function here called search. Let's take a look at how we are passing the array to search, and also how we're passing the number that the user would like to search for. Okay, so let's put this array back down to the proper size, which is 5. And it's initialized to these values right here. So let's search for the number 11 first. And so I'll move my breakpoint, or I'll disable that one, and I'll re-enable the breakpoint that I have right here. So execution will stop when we reach the call. So let's start the program, and I'll go ahead and search for 11. So 11 is in index 2, or is stored at index 2. So we have 0, 1, 2, and then 3 and 4. So 4 is our last index location, which is 1 less than the size. Okay, we're now stopped right before the call after I type return. So now we're stopped just before the call, and so what I would like to do is I would like to step into it. So I'll click the step in button. And when we get to search, we can take a look at the description of what the function does. Search an array and return the index location or not found. Okay, so I've set up a constant global up at the top of the code file called not found, and not found is set to -1. I've used -1 as the value for not found because all indices start at 0. So there's no way that a proper index can be -1. So -1 is a good value to signify that something wrong happened. So you can use it for errors, or to signify that something wasn't found, or failure, whatever you need. Okay, so index equals not found. Just like I did with the size of the array and the loop count limiter, I could use a literal here. I could use -1. But this is not a good idea, because -1 doesn't really mean anything. If I didn't know what you were doing with your code and I see this -1 right here, there's nothing that jumps out at me and tells me why you are using -1. At the very least, what you should do is you should put a comment here that says -1 means not found. So that's at a bare minimum that you would do that. If you don't have a comment or you don't use a constant global, then the other coders are not going to know what you're doing right here. So it's a much better idea to use a constant global such as not found, and then other coders can look at your code and tell right away what you're doing. Okay, so we've set up our local variable called index, and what we're doing is we are assuming that the number that we're searching for, search num, is not going to be in the array. So that's just our assumption, and that's how our algorithm works at this point. So the algorithm says, let's assume that the number they're searching for is not in the array, and then if we find it, we'll go ahead and update that information. So if the search number is found somewhere in the array, then we will update our local variable index, and we'll set it to the location where we found the value. And then once we find the value, it doesn't make any sense to keep searching, so we have a break statement right there, and then when we break, we'll jump down to return index. Okay, so we are searching for the value 11, and so we already know that that is at index 2. But what we need to do is we need to search every location, so we're going to start at 0 and we're going to stop when we reach the end of the array right there. Okay, so let's go around the loop a couple of times. 11 was not found at location 0, so the if condition is false, so we skip over this part. And we increment I to search for the next location. So I is now equal to 1, and so we're going to be comparing the array at index I to the search number. Well, that's not 11 either, so we skip over the loop again. But this time we're going to compare the array at location 2, and that does store 11. So our if condition will be true, which means we will execute index equals I. So index goes from -1 to 2, and we're going to hit that break statement, and then we're going to jump down to return index. So we are returning the location where we found search num. So that's how this function works. It tells us where in an array a value is found. So step over this one more time to return to the call, and then we're going to store the value that was returned from search inside the local variable back in main. We're back in main now. Loc will store 2 in this instance because 11 was found at index 2. Okay, so then we have an if structure right here. If the location is equal to not found, we say that we couldn't find the number. Otherwise, we say where the number was found in the array. So let's step over that. This is false, so we execute the else clause right there, and we say that the number was found at location 2. Okay, so that is how a search function works. And you can see that we also have this function called findMin set up. I've commented it out for now, and so let's discuss this function findMin in our next video. Okay, thanks.